Hello students, today once again I am here to discuss with you all a new topic in our first episode, that is chapter Light, Reflection and Refraction. We will start the chapter with the topic that is the light. So light is a form of energy that provides sensation of vision. That's why we can see the objects nearby. So we can take the example here. We can see the flower during daytime because it reflects sunlight falling on it into our eyes. So next example we can take of the night time. We can see the chair at night because it reflects bulb light falling on it into our eyes. So if we take several examples of in our surroundings, the objects can be categorized into two types. One is the luminous objects, that means the objects that emits their own light. And next one is non-luminous objects, that means the objects that doesn't emit their own light. So let's take few example here. So I've taken a simple example of the bulb for luminous objects. So there can be several other examples such as candles, torchlight, tube light, fire, etc. Those emits the lights. Okay, next example of non-luminous, we can take the example of flower. So there can be several other examples you can take by yourself for non-luminous and luminous objects. So let's have the properties of light. So number 1 point is light consists of electromagnetic waves. So does not require any medium or any material for their propagation or to travel. Light tends to travel in a straight line at very high speed. Light has dual nature, that is wave as well as particle. Light casts shadows and speed of light is maximum in vacuum. Its value is 3 into 10 to the power 8 meter per second. When light falls on a surface, following may happen. Number 1, reflection. Number 2, refraction. And number 3 is absorption. We will start now with reflection of light. The process of sending back the light rays which fall in the surface of an object is called reflection of light. So if we take the example here with the help of diagram, so when light falls on a mirror, so this light is reflected back into the same medium through the mirror. So maximum reflection takes place in a polished and shining surface. That's why in this chapter also we will begin with the plane mirror. An ordinary plane mirror has been coated with a silver color in the back part and that has been covered with the red paint. And the reflection of light in a plane mirror takes place at the silver surface in it. Now we will see in this chapter how a plane mirror is represented in a diagram. So in our diagram, a plane mirror is represented by a straight line having a number of short oblique lines on one side. That will be the back side of a plane mirror. So the reflection of light from a plane surface or from a spherical surface takes place according to two laws. Number 1 is angle of incidence is equal to angle of reflection, and second is the incident ray, the reflected ray and the normal at the point of incidence all lie in the same plane. Let's understand with the help of a diagram. So this diagram represents the reflection of light through a plane mirror. So mm dash is a plane mirror. So here in this diagram, if you see, I and R is representing the angle of incidence is I and angle R is angle of reflection. So angle of I is equal to angle R. So incident ray AO, normal NO and reflected ray BO all lies on the same plane of the mirror. So let's have an example here to understand more about angle of incidence and angle of reflection. So in both the diagram here, left hand side and right hand side, angle of incidence is equal to angle of reflection. So let's have a diagram for the normal. So a ray of light incident at 90 degree to the plane mirror and reflected back on the same path, that is called as the normal. So let's see about the image. So image is a point where at least two light rays actually meet or appear to meet. So there are two types of images. One is real image and another one is virtual image. Real image formed when light rays actually meet, and virtual image formed when light rays appear to meet. Real image can be obtained on screen and virtual image can't be obtained on screen. Real image is always inverted and virtual image is erect. So if you see the example of real image formed on cinema screen. An example of a virtual image formed by plane mirror. Real image is formed by concave mirror and virtual image is formed by convex mirror. So about concave mirror and convex mirror we will see in the latter part of this video. Okay. So the image of our face formed by a plane mirror cannot be obtained on a screen. It can be seen only by looking into the mirror. So the image of our face in a plane mirror is an example of virtual image. Now let's know how images are formed by a plane mirror. So this is the diagram representing the image formed by a plane mirror. So here AB is an object and A dash B dash is an image. Now we will understand more clearly here. So suppose this is a plane mirror, its reflecting surface is this one. If a person is standing in front of a mirror, so its image will be formed here. So this is object and this is image. So let's have its first characteristics. It is virtual. Image is virtual. So virtual is only formed in a mirror and real is on the screen. We have already discussed about the real image and virtual image earlier. So virtual image is formed only in mirror or on a lens. So next, the distance of the person or the object from the mirror, it is same as the distance of the image. Okay, they are equidistant. Next one, they are erect. How the object is, the same will be the image. They will be straight. And next one, they are lateral inversion. So what is the meaning of lateral inversion? So lateral inversion means the opposite. That means your right hand side becomes your left hand side. Okay, so these are the characteristics of image formed by plane mirror. So let's see what are the characteristics we have got by the image formed on a plane mirror. So number one is virtual and erect. Number two, size of image is equal to the size of object. Number three, image is formed as far behind the mirror as the object is in front of it. That means that they are equidistant, image and object. Number fourth is laterally inverted. So what is lateral inversion? The right side of the object appears left side of the image and vice versa. So if I take the application of lateral inversion, the word ambulance is written in reverse direction so that it can be read correctly in rear view mirror of vehicles going in front of it. So next we will discuss about the reflection of light from curved surfaces, that is spherical mirror. So a spherical mirror is a mirror whose reflecting surface is curved. And also such mirror are a part of hollow sphere of glass. There are two types of spherical mirrors. Number one, concave mirror. Number two, convex mirror. So concave mirror are generally in the shape of this one, and the outer side of the sphere is coated with the mirror paint and the ray is reflected from the inner side of the mirror. So if we talk about the properties of concave mirror has reflecting surface which is curved inward. So that's why it is called as the converging mirror. And next we have convex mirror. When we see the diagram of convex mirror, the inner side of the sphere is coated with the mirror paint and the outer side works as the reflector of the ray. So that is in the convex mirror. and its properties of convex mirror is reflecting surface is curved outward. So that's why it is called as the diverging mirror. So if we look over the diagrams of concave and convex, so we can see that all the reflected rays are converged in a single point, that is F. That's why it is called as the converging mirror. And in convex, all the light rays after reflection are deviated from its own path. That's why it is called as the diverging mirror. So let's know some of the common terms for spherical mirrors. So number one is principal axis, the line joining the pole and center of curvature. Next is pole, the center of the spherical mirror. Aperture, it is the effective diameter of the spherical mirror, and it is also known as the portion where actually reflection of light takes place. The fourth one is center of curvature, C, the center of hollow sphere of a glass of which the mirror is a part. So the next one is radius of curvature, R, the distance between the pole and the center of curvature. Next one is the principal focus, the point on principal axis where all the parallel light rays actually meet or appear to meet after reflection. The last one is focal length, denoted by small f, the distance between the pole and the focus. So let's understand the terms with the help of diagram. So suppose this is a concave mirror and this is a hollow spherical mirror or hollow spherical glass. So the center of hollow spherical glass, it is called as the center of curvature. Okay, so now this point I have denoted as P, it is a pole. So this pole is a center of spherical mirror. Okay, and the distance between C and P, it is called as the radius of curvature. Okay, it will be the radius of spherical mirror, and from C to P, it is called as the radius of curvature. So next, this line, the imaginary line, it is called as the principal axis, drawn through PC. So if I take the example of convex mirror also, so it is also a part of hollow spherical mirror. So this is center of curvature, this is pole, and this is principal axis. And this one is the radius of curvature. Okay, it will remain same, but the position will be changes. So next, if I talk about principal focus, so this is a concave mirror. So this is principal axis P, C, and this point I have denoted as F. So if you see here in the diagram, after reflection, all the light rays meets at a point that is F. And here also, if I draw convex mirror, so all the light rays after reflection, it appears to meet at a point. That point is F. So this point is called as the principal focus. So again, I am drawing the same thing, C, P, F. This radius of curvature. This is, now we are getting a new point, that is focal length, that is FP. So if I talk about principal focus and focal length, so we will say again using the diagram. Okay, so suppose this is concave mirror, this is principal axis, this is center of curvature, and this is a part of a hollow spherical mirror. This is radius of curvature CP, and this point, whatever we have taken earlier or talked about earlier, that whatever points, whatever the light rays after reflection meet at a point, that point is called as the principal focus. And from that point, principal focus to the pole, it is called as the focal length. From here, we will get a result as radius of curvature is double of focal length, and focal length is half of radius of curvature. So if I draw again a convex mirror, a part of spherical mirror, this is pole, this is center of curvature, this is F. So if you see here, after reflection in convex mirror, they appears to meet in a point that is called as the principal focus. Okay, now we will see about rules for obtaining images formed by concave mirror. For convex mirror, we will see later on. First, we will see here the rules. 1. So when the light rays incident on a concave mirror, after reflection, it passes through principal focus, that is F. So next rule, when the light rays incident through center of curvature, that is C, after reflection, it passes again through the center of curvature. Rule 3 is when the light rays incident through principal focus, after reflection, it passes parallelly to the principal axis. And the rule 4 is when the light rays is incident at pole making an angle I, so it will be reflected back making an angle R, so that I will be equal to angle R. So these are all 4 rules. I hope you have understand it. So students, this much for today. So here is the end of episode 1, and we will meet again in the next episode. Till then, thank you and take care.